Hey friends! Okay, so quick little, really boring quiz on the central limit theorem. I'd like to apologize too for this camera. I think it's still doing its weird focus thing. It's a brand new camera. Unfortunately, it's got a bit of a focus issue, so I'm going to get it returned and taken care of. Okay, first of all, a highly skewed population has an average of 23 and a standard deviation of 4, which of course you don't know. You never know those things. That's why you sample, so you can get an idea of those things. Take a simple random sample of size 100. Your sample's average is part of a sampling distribution. Okay. So here's the deal. The actual population's histogram, or draw histogram, I guess, is going to be highly skewed. I didn't mention which way it's skewed because I don't know. We don't know any of this stuff. So I'll just make it look kind of skewed to the left, I guess. They'll go way off, something like that. Okay. And that thing has an average of 23 and a standard deviation of 4. Okay. I don't even know where 23 is on that. Pretend it's right here. That's 23. Okay. Now, that is the population standard deviation, or excuse me, the population distribution. We don't know that. So we draw samples. The question is, what is the sampling distribution shape going to be? Not the population distribution, not the individual data points, but all possible samples taken from that population. That's going to be a bell curve. That's what we discovered in class about repeated sampling. So it's going to look something, and I'm not sure if I've got the shape 100% correct, because a lot of this is just supposition anyway. But that curve is going to look something like that. Okay? You may notice that I happen to draw, well, it's not perfect. I'm going to go fix it and make it perfect. I made the hump of the bell curve right on top of the average of 23. Because that's where it ends up. That's the answer to part 2. What would its approximate average be? 23. Because as we learned in class, the average of all the sample averages is equal to mu. That's awesome. So it's bell-shaped distribution. The average of the distribution is going to be mu. And here's like the super important part. Not that that's not super important, because that is. But even like kind of more super important is what's the standard error of that bell curve there? Well, the standard deviation of the distribution in the population is 4. The standard error of that bell curve shrinks with the size of the samples that you pick. The relationship is that the standard error is going to be equal to the population standard deviation over the square root of the sample size. So in this case, grab my orange chalk here, that's going to be 4 divided by the square root of 100, which is 4 divided by 10, which is 0.4. And there's a leftover 4 here from something else. So the standard error is going to be 4. 0.4, excuse me. Many 4s. So we know that the average of the sampling distribution is 23. And the standard error of that is 410.4. Okay. Questions 4 and 5 ask about ranges. All of the sampling distribution ranges. Okay. The key of these is the percentages I gave you, the 95 and the 97. In a bell curve, we've been doing this for a couple weeks now. 95% of the data are trapped within 2 standard deviations. And almost 100%, it's more like 99.7, are trapped within 3 standard deviations. That's the idea you want to use on this. Except that's for the bell curve of a population. We don't have the standard deviation of the population, so we have to sub in the standard error. So for number 4, it's going to be the sample average plus or minus 2 of the standard errors, which is going to be, so I can do this math in my head. It'll be 23 plus or minus 2 times 0.4, which will be 0.8. So on the low end, it's going to be 22.2. And if I add that, it's going to be 23.8. So in that bell curved sampling distribution, we're going to have 95% of the data between 22.2 and 23.8, which tells me that I drew it really badly. I drew it too wide. Assuming, let me see if I can find a color here. We'll use bright yellow here. Assuming that this is 0 and that's 23, it's going to be about 11. About 16. Yeah, the bell curve I should have drawn would have looked more like this. I drew one more of like a sample size of 4 as opposed to a sample size of 100. Look how close these numbers are, right? If 95% of the data in that distribution is between these two numbers, that means there's going to be almost no tail. It's all going to be humped up towards the middle. Apologies.
Please excuse the crudity of this model. I didn't have time to build it to scale or to paint it.
3 standard errors is the 99.7. So that's going to be, I'm going to bypass the symbols because I'm running out of space down here. It's just going to be 23 plus or minus 3 of those, which is going to be 1.2. So if I subtract 1.2, it's going to be 21.8. If I add 1.2, 24.2. There you go. There's your ranges of 2 and 3 standard errors around the mean. This is the one we're going to use most of the time in this intro class with inferential stats because it represents 95% confidence. But there's your primer. Very boring quiz. Cool ideas, but not that interesting. We'll get into more applications next time.